In the given circuit, I need to find the loop current IA. So I can see there are three loops. Let's assign the other two loop currents. Let's call it, let's say, IB, and this one IC. Now IB, since there is a current source of 10 ampere, IB will become, and the direction of current source is in the other direction of IB, so it will be minus 10. So that we can write directly. Similarly, IC, in this particular loop, we can see that there is a current dependent current source, actually voltage dependent current source, because this is the control voltage, and because of that the loop current IC will become, the one branch current is 2V phi over 5, so the current IC becomes 2V phi over 5. Now V phi is the voltage drop across 5 ohms resistance here. So let's first identify one thing. V phi can be written as 5 times the current going downwards, since the voltage drop is in this direction. So that will be IA minus 2V phi over 5, because the other current, this current is in the other direction, so it has to be subtracted. So this one can be written 5IA minus 2V phi, like that, and here it's V phi. So I'm just getting rid of the bracket, so it's now becoming 3V phi is equal to 5IA. So V phi can be written in terms of 5IA over 3. So I have expressed V phi in terms of IA because I need to find the value of IA, so I am just expressing V phi so that there is only one unknown in terms of IA V phi. So now I will write the loop current equation for the first loop, the KVL here. So if we start from here going in the clockwise direction, we can see this 75 volts is a rise. So let's write it on the left hand side, rise here. Then this 2 ohms, this will be drop in this direction, and the current will be, so what I will do, I will directly write the equation. So since there are two resistances, 2 ohms and 5 ohms, so addition 2 plus 5 is 7 ohms times IA, because IA is the loop currents. The other two current will come as negative, so sum of the resistances 2 plus 5 is 7. Now this current, which is IB, that will be minus 2 ohms, because that is the common resistance between loop A and loop B. So minus IB times 5, and then minus IC times will be the common resistance here is 5 ohms. So that's 2 actually, sorry, the first one, and this is 5. So instead of writing IB, we will write 10 ohms, and that will be 10 amps, and that is negative, so it will become 10 times 2. And then instead of IC, we will write 2V phi over 5, so that will become 2V phi over 5 times 5. So that is the value of IC, and this is the value of IC, so that's that. So it's becoming 75, and then 7IA and plus 20 minus, instead of so this is the 5 and 5 gets cancelled, so it will be 2V phi. So instead of V phi, I will write 2 times 5IA over 3. So I will write in terms of IA. So this is the value of V phi in terms of IA, so I have written in terms of IA there. So now it's like that. So 75 here, 7 is equal to 7IA here, plus 20 minus 10IA over 3. So let's multiply both sides by 3. 75 times 3 is 225. Here it's 21IA, here plus 60, and then minus 10 IA. So 225 minus 60 is becoming 165 here, and then 21, this is 11 IA, so IA is becoming 165 over 11, which is 15. So 15 amps is the loop current, the one that we were after.